the estimate at completion. We have created our baseline, found our planned value, actual cost, earned value. What does this earned value actually mean? Well, if you see that dot on the cost baseline, right, that might remind you that at the very beginning of our explanation about earned value, I was saying that earned value is actually a point on the cost baseline. It's the point on the cost baseline which represents the amount of work that I've really done, right? So while I should be at planned value, that's where I had planned to be, where am I in reality? I'm behind schedule, I'm at the earned value, I'm down here. If you were to measure this on the time axis, the difference between the point on the cost baseline where the earned value is represented and today, that would represent my delay, right? However, let's have a look at what this actually means. If you look at the cost baseline, this means that all the work done from the point 0 of the axis all the way until the earned value, that's the amount of project work that I have completed. That's the work done. Instead, the work from the earned value onwards until the end of the project, that's the work left, the work still to be done, right? While in reality, I've spent money, cash out the pocket, the actual cost. Right? So my question is, if this big dot down here on the earned value is where I'm actually standing and the actual cost is how much I've actually spent, how much will I actually spend by the end of the project, right? That's what we call the estimate at completion. Where is the estimate at completion going to be? Well, there are two basic approaches which are very easy that are good to learn, right? That they help you in creating your overall estimate. Okay, let's have a look at it. First of all, remember that the budget at completion represents the total amount of work that you need to do by the end of the project, right? The budget at completion. While the actual cost represents the total amount of money that I've spent so far, right? The earned value instead represents the total amount of money that I had planned to spend for the amount of work that I've really done, okay? Three very different concepts. So the question is, what is the situation with this deviation? I had planned to spend the earned value for the amount of work I've really done, but in reality, I've spent the actual cost for the amount of work I've really done. So now I need to ask myself the question, can I fix the root cause behind this deviation, or can I not fix it? This is the first most important question. So let's assume that we decide that yes, we can fix the root cause behind the deviation, right? So this is the assumption that we are making. Given our situation, we can fix the root cause behind the deviation. So in this case, what does it mean? It means that until today, the effect of the deviation has impacted my cost. I wanted to spend the earned value. I've in reality spent the actual cost. But I've identified the root cause for the deviations. I can fix it, and I have fixed it. Therefore, from today onwards, this deviation should not impact me any longer. The rest of the cost baseline should be respected. I simply need to take, since nobody is going to give me the money back that I have already spent, I simply need to take the deviation I've had so far, move it down to the end, because that's the only deviation that I will have. I will not have new deviation, right? So if I take the deviation that I've had so far, put it up on the top of the budget at completion, that should represent the expected estimate at completion that we will have in reality, right? So very simple. I take my original budget at completion and add to it the difference between what I've really spent, actual cost, minus what I had planned to spend, the earned value, right? So that's the first formula that you need to remember for the earned value. Budget at completion plus the difference between the actual cost and the earned value. Very, very simple. Now, what happens, however, if we cannot fix it? What happens if we assume that the deviation that we've had so far is in reality going to continue impacting us throughout the arch of the project? In that case, obviously, the deviation that we've had so far is going to continue also into the future, right? So we need to take in consideration this additional deviation. So if we want to take in consideration this additional deviation, we will assume that the budget at completion will be skewed by the same percentage as my earned value has been skewed and became the actual cost, right? We're assuming it to grow by the same percentage. So let's have a look at it. The first thing that we want to understand is that actually what we're saying is that the deviation we've had so far in percentage is the same as the deviation we're expecting at the end in percentage, right? Because we have this deviation which is skewing us towards that direction. So this is the assumption that we're making. The deviation that we've had at the end of that we will have at the end of the project, the deviation from the budget at completion to the estimate at completion, what we really will spend versus what we wanted to spend, this deviation, we're assuming that in percentage, it's the same as what we have spent versus what we wanted to spend by today. Okay, remember that in both cases, estimate at completion 1 and in estimate at completion 2, we're assuming that there will be no new deviation, right? But in the first case, we're assuming that the original reasons for the deviations have been fixed, therefore there is no increase in the deviation. In the second case, we're assuming that the original reasons for deviation are still there, therefore they will continue to impact the way I work. So I'm assuming that the original deviation, actual cost divided by earned value, will continue also into the future. Estimate at completion divided budget at completion. So what happens now? What happens is that we resolve this equation by the estimate at completion. We take the budget at completion, move it to the other side, it becomes multiplied from divided, therefore budget at completion multiplied by actual cost divided by earned value. Now, actual cost divided by earned value, you might remember, is the inverse of the CPI, right? The cost performance index, in fact, was earned value divided by actual cost. So actual cost divided by earned value is nothing but the inverse of the CPI. So let's put the CPI down at the bottom of the equation, right? And we say estimate at completion is equals to the budget at completion divided by the cost performance index. This is the second equation that you need to remember, where essentially the deviation we have today is the same in percentage as the deviation we will have at the end of the project. So these are the two formulas that you need to remember. In case we can fix all the root causes for deviation, we only will have the increase by the amount of money that we've already additionally spent. That's the first estimate at completion. In case we cannot change the deviations, we will have the percentage impacting us for the rest of the project. That's the second formula. There's also a third formula that you can remember if you want. While the first two are most important, but it's good if you remember also this one, especially if you're preparing for a project management certification. However, the first two are the ones that you really need to remember. Your first estimate at completion, remember, was budget at completion plus actual cost minus EV. We can rewrite this as actual cost, nobody is going to give us the money back that we've already spent, plus the work that is still left over, budget at completion minus earned value, right? The logic stays exactly the same. I've just turned these two around. However, what this means is I have already spent the actual cost. In addition to the money I've already spent, what will I still spend? Well, my budget at completion has been assumed, or my baseline has been assumed to be correct from now on. From now on is represented by budget at completion minus what I've already done, the earned value. And the second case was the budget at completion divided by CPI. Now, if I put these two cases together, and I'm assuming that both cost performance index and schedule performance index will be impacting me, for example, because I planned for quite a lot of delay and I'm assuming that this delay will create additional impact on my cost, I can consider this new scenario, right, where I say estimate at completion is equals to the actual cost, like in the first case, plus budget at completion minus EV, plus budget at completion minus EV, but the future portion of this work, budget at completion minus EV, is divided not only by the CPI, like in our EAC2, but by both CPI times SPI. Now, do keep in consideration that if both CPI and SPI are less than 1, for example, I am a little late and a little over budget, so they are both 0.9. If I multiply 0.9 times 0.9, I have 0.81. Essentially, I'm creating a more or less artificial worst-case scenario. On the other hand, however, if I have 0.9 CPI but 1.1 SPI and I multiply them together, I am washing off the deviations. So this formula here, you should only consider it when both CPI and SPI are less than 1. And you do it with the explicit purpose of creating a worst case scenario. Okay, that's the objective of this EAC3. The next topic that we will be touching is the to complete performance index. Right? And this is quite a useful index to use when evaluating the future.